Hello everyone, today let's solve a Google interview question. You are given a list of intervals and an integer. You have to return the intervals that contain the required integer. To solve this problem, let's answer a simple question. How do you know whether an integer is inside an interval? For example, we have integer 2 and an interval from -3 to 0. In this interval, the right endpoint of the interval is 0, which is less than 2. It means the whole interval is located on the left side of the integer 2. How about this interval, I and 8? For this interval, the right endpoint of the interval is 5, which is bigger than 2. It means the interval from 5 to 8 is located on the right side of the integer 2. How about this interval? This interval is containing integer 2 because this interval from 1 to 3, neither on the left or right side of the integer 2. From this easy question, we can see that we can build a tree structure to solve the interview problem. In the tree structure, each node will contain the interval covering the specific integer, and its left and right nodes, which are the intervals that the integers stay outside. For example, we have such a list containing 3 intervals. To create an interval tree, we split the list into half. The central element is the interval -1 to 5. Choose -1 as a reference integer. Compare all right endpoints of the interval in the list with -1. They are all greater than -1, so there is no left node. Then compare the left endpoint of those intervals with -1. We found interval 2 and 4 and the interval 6, 8 are all on the right side of the integer of -1. So the root node has a value -1 and the interval is from -1 to 5. Now we repeat the same process for the remaining interval, which are interval 2, 4 and the interval 6, 8. We end up with the interval tree look like this. They are almost there, just need 2 more information for the interview problem. We want to sort the interval on each node by their left and right endpoint. With this process, we can find all qualified intervals very quickly. For example, for interval 2, 4, we sort it by left endpoint. We have this, the left endpoint. Since it only has one interval, we got this information. And sort by the right end point 4 and the interval. The same go here. The left endpoint sorting, the right endpoint sorting. After with building the interval tree, We just need to go from the bottom of the tree up to the top, compare the target integer with the node value, and find all the qualified intervals. Okay, let's look at the code. First, we need a binary tree class. It contains a value, 2 sorting information, and 2 pointer. Second, we need a function to convert the list of intervals into our defined binary tree. In this function, we recursively split the list to build an interval binary tree. For more information about converting a list to a binary tree, you can watch my previous video. The link is listed below. Last is our main function to find the interval containing the target integer. In this function, if the target number is less than the value of the node, we go down along the left branch of the tree and find the qualified intervals by the low limit sorting information. If it's greater, we go down along the right branch of the tree and find the interval by the high limit sorting information. That's all for today. See you in next episode.